Chapter 8, Part 1. Chapter 8, Part 1. Plyometric Training Concepts. Chapter 8, Part 1. Chapter 8, Part 1. Plyometric Concepts. Learning Objectives. Upon completion of this chapter, you will be able to describe plyometric techniques and their purpose in performance enhancement and injury prevention. Describe the role of plyometric training in improving sports performance. Identify the attributes of a progressive plyometric training program for athletes in any level of training. Page 270. Chapter 8, Part 1. Muscles' ability to exert maximal force output in a minimal amount of time, also known as rate of force production, enhances their performance during functional activities. Muscles' ability to exert maximal force output in a minimal amount of time, also known as rate of force production, enhances their performance during functional activities. All else being equal, success in most functional activities depends on speed at which muscular force is generated. Power output and reactive neuromuscular speed at which muscular force is generated. Power output and reactive neuromuscular control represents a component of function. Power output and reactive neuromuscular control represents a component of functional. Power and reactive neuromuscular control are perhaps the best measures of success in activities that require rapid control. Power and reactive neuromuscular control are perhaps the best measures of success in activities that require rapid force production. Plyometric training, also called reactive training, makes use of the stretch shortening cycle to produce maximum force in the shortest amount of time and to enhance neuromuscular control, efficiency, rate of force production, and reduce neuromuscular inhibition. Wow. The stretch shortening cycle. Plyometric training, also called reactive training, makes use of the stretch shortening cycle to produce maximum force. Stretch shortening cycle, maximum force in the shortest amount of time, and to enhance neuromuscular control efficiency, rate of force production, and reduce neuromuscular inhibition. Definition: stretch shortening cycle, an active stretch, eccentric contraction of a muscle, followed by an immediate shortening, concentric contraction of the same muscle. Stretch shortening cycle, an active stretch, eccentric contraction of a muscle followed by an immediate concentric contraction. Boom, explosive of the same. So when you go down on a squat, that's your eccentric, and you explode up, jump out. Plyometric training concepts. Plyometric training is defined as a quick, powerful movement involving an eccentric contraction followed immediately by an explosive concentric contraction. This is accomplished through the stretch shortening cycle or an eccentric concentric coupling phase. The eccentric concentric coupling phase is also referred to as the integrated performance paradigm, which states that in order to move with precision, force must be loaded eccentrically, stabilized isometrically, and then unloaded, accelerated concentrically. Plyometric exercises stimulates the body's proprioceptive and elastic properties to generate maximum force output in a minimum amount of time. Plyometrics training definition. Plyometric training exercises that utilize quick, powerful movements involving an eccentric contraction immediately followed by an explosive concentric contraction. Research continues to accumulate that demonstrates the value of plyometrics among athletes of all ages, showing how important plyometric training is for the enhancement of speed, increasing vertical jump, increasing strength, and improving agility. The neuromuscular system must react quickly and efficiently following eccentric muscle action to produce a concentric contraction and impart the necessary force or acceleration in the appropriate direction. Therefore, specific functional exercises that emphasize a rapid change in direction must be used to prepare each athlete for the functional demands of the specific activity. The goal is to teach athletes to perform specific movements in an efficient manner to accomplish their fitness or performance goals. Efficient manner. Efficient. Plyometric training offers the opportunity to train specific movement patterns in a biomechanically correct manner at a more functionally appropriate speed. This provides functional strengthening of the muscles, tendons, and ligaments specific to the demands of everyday activities and their sport. The ultimate goal of the plyometric training is to improve the reaction time of muscle action spectrum, eccentric deceleration, isometric stabilization, and concentric acceleration. By improving the reaction time through the muscle action spectrum, the athlete will also see a transfer of benefits in the development of agility. By improving the reaction time through the muscle action spectrum, the athlete will also see a transfer of benefits in the development of agility. The speed of muscular exertion is limited by neuromuscular coordination. This means the body will move most effectively and efficiently within a range of speed the nervous system has been programmed to allow. Plyometric training improves both neuromuscular efficiency and the range of speed set by the central nervous system. Optimum reactive performance of any activity depends on the speed at which muscular forces can be generated. Blue box. Research in focus. Side note. Using reactive training for injury prevention and performance enhancement. Reactive training is traditionally known to be important for the development of athleticism. However, many studies have shown the efficacy of the use of reactive training for injury prevention as well. The benefits of reactive training include improved control for various and valgus movements at the knees during landing, enhancement dynamic knee stability during this deceleration phase of landing, enhanced anaerobic power and vertical height jump, enhanced anaerobic power and vertical jump height, improvement in overall power and change of direction, speed in all planes of motion. Three phases of plyometric exercise. 3 phases. There are 3 distinct phases involved in plyometric training, including the eccentric or loading phase, the amortization or transition phase, and the concentric or unloading phase. The first stage of a plyometric movement can be classified as the eccentric phase, but also has been called the deceleration, loading, yielding, counter movement, or cocking phase. This phase increases muscle spindle activity by pre-stretching the muscle prior to activation. This phase increases muscle spindle activity by pre-stretching the muscle prior to activation. Potential energy is stored in the elastic components of the muscle during this loading phase. A slower eccentric phase prevents taking optimal advantage of the myotic stretch reflex. Myotic stretch reflex. Myotic stretch reflex. A slower eccentric phase prevents taking optimal advantages of the myotic stretch reflex. This phase increases muscle spindle activity by pre-stretching the muscle prior to activation. That's the eccentric phase. Amortization phase. This phase involves dynamic stabilization and is the time between the end of the eccentric contraction, the loading or deceleration phase, and the initiation of the concentric contraction, the unloading or force production phase. That's concentric. The amortization phase, sometimes referred to as the transition phase, is also referred to as the electromechanical delay between the eccentric and concentric contraction, during which the muscle must switch from overcoming force to imparting force in the intended direction. A prolonged amortization phase results in less than optimum neuromuscular efficiency from a loss of elastic potential energy. A prolonged amortization phase results in less than optimal neuromuscular efficiency from a loss of elastic potential. A rapid switch from eccentric contraction to concentric contraction leads to more powerful response. The concentric phase or unloading phase occurs immediately after the amortization phase and involves concentric contraction and results in enhanced muscular performance following the eccentric phase of muscle contraction. This occurs secondary to enhanced summation and reutilization of elastic potential energy, muscle potentiation, and contribution of the myotic stretch reflex. This occurs secondary to enhanced summation and reutilization of elastic potential energy, muscle potentiation, and contribution of the myotic stretch reflex. Physiological principles of plyometric training. Physiological principles of plyometric training. Plyometric training utilizes the elastic and proprioceptive properties of a muscle to generate maximum force production. By stimulating mechanoreceptors to facilitate an increase in muscle recruitment in a minimal amount of time. Muscle spindles and Golgi tendon organs provide proprioceptive basis for the plyometric training. Provide the proprioceptive base for plyometric training. The CNS then uses this sensory information to influence muscle tone, motor execution, and kinesthetic awareness. Stimulation of these receptors can cause facilitation, inhibition. Stimulation of these receptors can cause facilitation, inhibition, and modulation of both agonist and antagonist muscle activity. This enhances neuromuscular efficiency and functional strength. One overlooked benefit of plyometric training is the effect plyometric exercises have on the energy cost of running. It has been demonstrated that running performance can be improved with a well-developed and targeted plyometric training program. This suggests that an athlete can decrease the amount of oxygen and energy needed to run at the same speed with plyometric exercises designed specifically for the runner. The effect is believed to be caused through the stiffening of muscles and tendons being trained. This stiffness reduces the amount of energy lost when running, increasing the amount of energy that the athlete is able to utilize in their performance effort. The integration of plyometrics with cardiorespiratory training is important to improve overall running performance. Pro tip, page 273. Pro tip, page 273. Chapter 8, plyometrics. Adaptation exercises. Adaptation-specific plyometric exercises are vital when seeking to enhance performance. For runners, linear plyometrics may be best for development of running economy. The elastic properties of muscle. The concept of plyometrics is based on the three-component model of muscles. Muscle is molded with contractile element and two elastic elements that are named according to their relationship to the contractile element. One in sequence with it, the series elastic element, and one parallel to it, the parallel elastic element. When a muscle contracts, tension is not directly transmitted to the ends of the tendon, and the load is not overcome, leading to movement. When a muscle contracts, tension is not directly transmitted to the ends of the tendon, and the load is not overcome, leading to movement. When a muscle contracts, tension is not directly transmitted to the ends of the tendon, and the load is not overcome, leading to movement. This would only happen if the connection between the contractile element and its insertion were rigid and inelastic. In reality, the contractile element develops tension, stretching the series elastic element. In reality, the contractile element develops tension, stretching the series elastic element. The degree of stretch is dependent on the load to be moved. Once sufficient tension has been generated, the tension at the ends of the muscle is sufficient to overcome the load, and the load is moved. When a load is applied to a joint, eccentric phase, the elastic elements stretch and store potential energy, amortization phase, prior to the contractile element contracting, the concentric phase. An eccentric contraction immediately preceding a concentric contraction significantly increases the force generated concentrically as a result of storage of elastic potential energy. During the loading of the muscle, the load is transferred to the series elastic components and stored as elastic potential energy. The elastic element series, elastic components are stored as elastic potential energy. The elastic elements then contribute to the overall force production by converting the stored elastic potential energy to kinetic energy, which enhances the contraction. The muscle's ability to use the stored elastic potential energy is affected by the variables of time, magnitude of stretch, and velocity of stretch. The muscle's ability to use the stored elastic potential energy is affected by the variable of time, magnitude of stretch, and velocity of stretch. Increased force generation during the concentric contraction is most effective when the preceding eccentric contraction is short range and is performed without delay. A simple example of the use of the energy stored in the elastic element is the basic vertical or counter movement jump. The initial squat, the counter movement, is the eccentric phase that stretches the elastic elements and stores elastic energy, amortization phase. Stores elastic energy, amortization phase. When the jump is performed, the concentric phase, the stored energy, is added to the tension produced, leading to a higher jump. The amount of stored energy used is inversely proportional to the time spent in amortization phase. When performing a vertical jump, the longer one pauses at the end of the counter movement before performing the jump, the lower the eventual jump height due to the inability to recover their stored elastic energy. The improved muscular performance that occurs with a pre-stretch in a muscle is the result of the combined effects of both the storage of elastic potential energy and the proprioceptive properties of the muscle. The percentage that each component contributes is unknown at this time, but the degree of muscular performance, as stated above, is dependent upon the time in transition from the eccentric to the concentric contraction. Integrated training enhances overall human movement system, neuromuscular efficiency. Integrated training enhances overall human movement system, neuromuscular efficiency. Training that enhances neuromuscular efficiency decreases the time between the eccentric and concentric contraction, thereby improving performance.